We are right on the edge of a world just full of autonomous machines. We're talking everything from delivery drones to self-driving cars. But here's the thing. This massive leap forward comes with a monumental challenge. In a crisis, how does a machine make an ethical choice? I mean, how do you actually code a conscience?
This is it, the classic driverless dilemma. It's basically the trolley problem for the 21st century. In a crash you just can't avoid, the car has to make a split-second call. So what should its priorities be? Who or what are we programming it to save?
For decades, philosophers have been debating these questions. But for the engineers who are actually building these cars, it depends just doesn't cut it. They need concrete, quantifiable rules, and that's exactly what we're diving into today. How we can move past pure theory to find a data-driven blueprint for machine morality.
So how do you get from what if to here's what to do? Well, researchers have come up with a really fascinating new way to think about this. It's not just about debating ethics anymore. It's about programming them directly into a machine. They call it an ethical goal function, or EGF. The easiest way to think about it is like an ethical recipe. It's a mathematical formula that takes our collective moral preferences, what we as a society actually value in a crisis, and turns them into a calculation the car's AI can use to weigh its options. Okay, so the researchers had a really clear two-part mission. First, they had to figure out the weight of our ethical ingredients. In a crash, what do we really care about the most? Then, second, they had to take all that data and use it to build a model, that ethical goal function, that could make decisions reflecting our actual human choices. To get to the bottom of this, they set up a really clever experiment. The whole point was to force people into making these super tough calls, because it's in those impossible trade-offs that our true values really start to show themselves. And this is how they broke morality down into parts they could actually measure. They came up with 6 key ethical ingredients for every scenario. You've got the obvious one, physical harm, but then it gets way more nuanced. We're talking psychological damage, moral responsibility, like who's at fault here, and even this concept of fair innings, which is a way of thinking about a person's age and how much life they've had a chance to live. So people in the study were hit with thousands of these just agonizing choices. For instance, imagine having to choose, do you swerve, break the law, and cause a minor injury to avoid hitting a child? Or do you stay the course, follow the law perfectly, but cause severe psychological trauma to an elderly pedestrian? I mean, there are no good answers here. But by forcing people to make these choices, a really clear pattern of our collective values started to emerge. All right, so after all those impossible choices, what did we actually learn? What did the data reveal about our shared moral code? Let's get into the findings and see how this blueprint for a machine's behavior started to take shape. The first huge discovery? The model they built could predict a person's choice with almost 64% accuracy. Now that might not sound like a home run, but think about it. It's way, way better than just flipping a coin. It proves that our ethical choices aren't just random noise. There are clear, consistent patterns in how we weigh these awful options, even if there's still plenty of human unpredictability. But here's where it gets really interesting. The biggest pattern they found was that we don't use the same moral rulebook for every situation. The researchers sorted the dilemmas into 2 buckets: critical scenarios, where we're talking severe injury or death, and non-critical ones, where the stakes are a lot lower. And that distinction, it turned out to be everything. In those critical life-or-death situations, one factor was king: physical harm. The data is crystal clear. People would much rather choose an outcome with a severe injury than one where someone dies. When we're faced with the absolute worst-case scenario, our main instinct is just to minimize the loss of life. Simple as that. But watch what happens when you take severe physical harm off the table. Our priorities do a complete 180. In these non-critical scenarios, get this: avoiding severe psychological trauma becomes the single most important thing. It's valued even more negatively than causing minor physical injuries. It suggests that as soon as our survival is pretty much guaranteed, we place a massive value on protecting our mental well-being. And you have to remember, this isn't just a bunch of cold, hard data. The researchers also got feedback from the participants, and it really shows the human struggle behind these choices. People felt deeply conflicted, especially about things like age. This quote here really captures that uncertainty and the emotional weight of it all, reminding us that even when you find patterns, there's rarely an easy answer. So what's the big takeaway here? This whole ethical goal function thing,
It's not meant to be the final word. It's not some perfect moral code set in stone. The whole point is for it to be a starting line for a system that can learn and evolve right along with us and our own values.
And the way they propose to do that is with this concept they call a socio-technological feedback loop. It sounds complicated, but it's basically a four-step cycle that just keeps repeating. Societal input, from studies just like this one, shapes the design. Then you have lawmakers providing governance, engineers build and test the system, and here's the crucial part. Real-world data from the cars in operation feeds back into the system to constantly refine and update its ethical programming. It's designed to be a living system.
All right, let's wrap this up with the big takeaways. What should you remember from all this? First, it seems we can actually translate our complex, messy human ethics into a mathematical formula a machine can use. Second, our moral compass isn't fixed. It changes dramatically depending on how high the stakes are. Third, never, ever underestimate the importance of psychological harm. When our physical safety is secure, it becomes priority number one. And finally, none of this is going to work unless the system is designed from the very beginning to learn and adapt right alongside us. This research is without a doubt a huge step forward. We're moving from just talking about this stuff to actually building it. But it leaves us with one heck of a question to chew on. As we teach machines to mirror our values, can they ever really capture the messy, complicated, and deeply human core of what it means to make the right choice? Something to think about as this tech becomes more and more a part of our world.